In this video, we want to look at a couple more numerical limits, and just a brief reminder, even as we develop other methods later to do limits, that'll allow us to do them a little bit quicker. If you are asked to do a limit numerically, we are expecting that you look at numerical values close to the number, so you're making a table, in other words. So here we have a limit as x approaches 2 of the fraction x squared plus x minus 6 over x minus 2. Before we even start making our table, a very important idea needs to be kind of brought up. And that is, if you try to plug in 2 into this equation, into this expression, you're going to have division by 0, and you can't even do it. That thing is not defined at 2. So there actually is no value of that function at x equals 2. Yet it may still have a limit. To find its limit, we, just like the previous example, construct the table x and f of x, and we're going to be looking at values. We're going to look at values of x that are close to 2, both below 2, a little bit below 2, and a little bit above 2. So typically I go a tenth, a hundredth, and a thousandth below, and a tenth, a hundredth, and a thousandth above. In some cases you may need to add a few more values to see what the pattern is, but generally this is the idea. And we want to go in and evaluate. And this is where the table feature of your graphing calculator is very helpful. So you can go in and plug those amounts in. So when we plug 1.9 in, it turns out the answer gets spit back out to us is 4.9. And then we continue doing the same thing. At this point you may want to pause the video and practice doing this in your table menu on your graphing calculator. And so we continue now. When we plug in 1.99, we get 4.99. And 1.999, we get 4.999. So it certainly seems like it's settling in towards a very particular number. But let's look on the other side, because we have to look from both sides to be sure. So we start with 2.1, and when we plug that in, I get an answer of 5.1. And then I plug in 2.01, and that spits out 5.01. And then finally plugging in 2.001, I get 5.001. So it certainly seems now that this is definitely settling into a value. Even though the original expression, you actually cannot plug 2 into it. This does have a result. And the result in this case is 5. So the limit here is 5. Let's turn to a second example. The limit as x approaches -1 of x plus 2 over x plus 1. Like the problem above, this problem, if we try to just plug -1 in, we would be dividing by 0. So we can't, unlike that polynomial, the first example, we can't evaluate this. We're not able to evaluate this. So we construct the table, though, to see what does it approach, if anything. And again, looking at values just a little bit smaller than -1, and values a little bit bigger than -1. So I would go at -1.1, -1.01, -1.001. Those are the things that are a little bit smaller. And the things a little bit bigger, -0.9, -0.99, and -0.999. And once again, we want to go into that function and evaluate it. And this is a great place, for you to pause and try out your table feature just to get practice. It's the quickest way to do these problems. Far and away, saves you a lot of computation time. And so, going through now and evaluating, -1.1 spits out an answer of -9. -1.01 spits out an answer of -99. And finally, -1.001 spits out an answer of -999. So that's not looking good as far as it's settling onto a value. It's just continuing to get bigger. But let's go ahead and look at the other side and see if maybe we can get some kind of information out of that. So when we plug -0.9 into that equation, we get an answer of 11. And negative 0.99 gives us an answer of 101. And finally, a negative 0.999 gives us an answer of 1001. So as we try to see what's this approaching, we say, well, there's a bit of a problem. It's not settling into anything. On the left-hand side, it's getting bigger and bigger negative numbers. On the right-hand side, it's getting bigger and bigger positive numbers. If you continue this, you're going to keep getting bigger and bigger. So this is not settling on to anything. So we say the limit does not exist, which will often abbreviate capital D and E for does not exist. Right? It's not approaching anything. In fact, it's actually on the left getting really small in the negative direction. Right? It's going down, 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 down. And on the right, it's getting really large in the positive direction. Okay, so these are limits numerically. In upcoming videos, we're going to look at limits from a graphical point of view. And that should give us a little bit more of an understanding of how limits work and how they're different from just plugging the number in to get an answer like you've done in the past with functions.